Good evening, everyone. Today's session is on block diagram of computer. Let us see how the computer architecture is organized and what are the different components in a computer. How we have different like systems. What is the growth? What is the evolution of computers? How we have different types of computers and what are the different applications of computer. So let us begin with the session and let us move into the detailed part of that, like how a computer comes into this picture, like how what is the block diagram of computer, right? So let's start with this. A computer system, basically what is it? A digital computer is considered to be a calculating device that can perform arithmetic operations. Yes. So why there is a need of a computer? So if you need to, if you want to perform any mathematical operations, or if you want to solve your problem, you may be using any system, right? So like you have in a small way, you may in a small thing you may be using your calculators, right? Like this only we have to develop as a computer, for it is going to help out the human beings. It is basically automating the processes. And nowadays, without computer, without knowing computers, it would be like helpless kind of thing, right? When you become when you are going or when you are doing any job also, you need to know the functions of computer, how computer works, and the basic things like how to create a file, how to store that file, how to use, how to make presentations, how to have your like PowerPoint, or there are nowadays there are number of online tools or as well which we use actually, right? Now let us see some of the examples in which we have, you may like how to use the computer, right? So let's begin with the session. It is defined as a device that operates upon information and data. So when you have data and when you have enormous data, so it you cannot have in your mind. You have somewhere like it is stored, and later on you may refer it, right? So there is a requirement of a system, or there is a requirement of a computer. To be able to process data, that computer is made up of various functional units to perform the specific task. So basically it is not only about performing the task, it is about how we basically use the data, how we give the input to the system, how it process it, and where it is stored, which basic units are used for doing the calculations, for performing the calculations, and then later on there are number of devices for showing the output, right? So there is a flow also, flow of data, and there should be a control between different devices also, right? So first of all, let us start with the architecture part. Let us start with the diagram of this, how it works actually. So at first we have a data. It could be an input data or whatever data you want to store it, right? Now it is given as an input using any input devices, right? There are a number of input devices through which you can give the input to the computer. And then now when a computer receives the information through application programs, it may be like storing those programs, it may be working on it, right? So how, what is the basic architecture behind that? As soon as it receives the data, right, so you have the storage part beyond that, right? First is you have the secondary storage, and then you have the primary storage, right? This is the secondary storage and this is the primary storage. So where you are basically storing your data, right? And then it is connected to the CPU, because CPU is the main thing which is going to allocate your uh, processes, right? So CPU is again having three types of things, like arithmetic and logical unit, which we call it at ALU. We have control unit, right? And the third is memory unit. In memory unit, or you may say a storage unit, it consists of two types of memory or two types of storage. And You may have an optional storage also, and most of the system nowadays there is the another one also, that is we call it as cache memory, right? So we can have our primary storage may we can say it as main memory. Secondary storage, maybe you will be using some pen drives, floppy disks earlier we were using. You have some hard disk, SSDs. You have number of devices that are storage devices, right? Secondary storage devices. Now like if the CPU is calling any function, if the CPU is calling any process and it is fetching the instruction from the memory, so first it's access the cache memory, right? And after that, like if the page is not found, if the information, if the data is not found in the cache memory, it would be searching in the primary storage, right? And then some translation or some page replacement kind of thing should be like in the process. And then after that, it when it fetches the interaction, it shows to the, it basically gives furnishes the request to the user as an output, right? So here we have number of output devices to we can give our output, right? And then we can get a processed information, right? Now we get an information. So this is how a complete flow works, starting with data and ending with you are getting some information out of it, right? So how it works, there is a number of things, number of hardwares and number of softwares that are involved in this. It is not going to be like it's a very easy task. And yes, nowadays there are number of processors. You have Intel processors, you have microprocessors. Nowadays we are using chips also, you have silicon chips. So earlier, like we were using vacuum tubes, then transistors, then ICs, then nowadays we are using the very microprocessor chips. So basically, it made a difference, right? For storing such a huge amount of memory, we have certain single chip is used, right? So this is what the basic thing which is beyond, which is behind our architecture of computer. Right now let us see some of the some part which is like in detail what we can have in our different parts. Like we have our input unit, like we have our storage unit, right? And then we have our output unit. So basically in detail we will be studying one by one, like what is input is what is the role, what is the function of input unit, what is the role of your CPU or you may say storage unit, and then we have your output unit, right? So let's go into the detailed part of that. So input unit basically consists, it computer needs to receive some information or instruction. Now how it is going to receive if there is no input device, right? So therefore we need to input the data and instructions into the computer using input devices, right? The input unit consists of one or more input devices, right? It could be like your keyboard, it could be your mouse, anything. It could be a scanner, it could be a microphone through which my voice is like recorded or something like that, right? All these are basically input devices and it has their own function. What is the function of that? What is the role of this input devices? It takes the data, it accepts the data and instructions from the outside world. So basically in between we have application programs, right? We are giving the input, right, using any input device. But to whom we are giving, there are certain applications program behind that. We have OS basically, which is allocating all this hardware, which is handling, which is managing, monitoring all the hardware devices behind our APIs. So we first of all we have input devices, then we have application programs, and then we have system softwares like operating systems, and then we have our memory chips or this kind of thing, which is basically allocating our hardware to the number of users which is accessing that particular system. So this is how it actually works, right? The second thing is it converted to a form that computer can understand. So whatever we are writing, it is not understood by the computer, right? So it is going to converted into the computer language. Yeah, it is must, because computer is only computer understands only 0 and 1. So machine language should be there behind that, right? and supply the converted data to the computer system for further processing. So when it receives the data, it is going to be converted, it's going to be processed, right? So that our input should be processed, should be solved, should be fetched. Our data should be fetched from some storage area, and then uh, from where it is fetched, so from some storage area, or it is searched, or if it is computed or calculated, any function, you may perform any function. So it is where it is there in the storage unit. So second part of this is a storage unit. Storage unit of the computer holds data and instructions that are entered through input device. So I told you, first of all we have the input devices, yeah, input unit, right? Then we have the storage unit. Now whatever we have received, whatever we have received from the input device, now that is going to be processed. Sorry. It preserves the intermediate and final results before these are sent to the output devices. So it is not directly like given to the output devices. First you search it, whether it is, like suppose I am searching anything on my system, right? I have, like suppose I'm searching for some PDF or some PPTs. So I'm giving some instruction through any typing something. This is that kind of process. I'm typing through my keyboard. So my input device, my input unit will be my keyboard, and then it is given to the computer for processing. Like I'm searching for PowerPoint, some file name is this, then computer is going to search and relocate that location, right, of that particular file. And then once it searches in the memory and it gives you the output, then only it is going to provide you some output through monitors, or you may say whatever the output devices it is going to use, right? So it preserves the intermediate and final results before these are sent to the output devices. It also saves data for the later use. I told you, whenever we have number of data, it cannot be stored in our mind. We need to store, we need to come out of that, and we need to store that part, right? So where we are going to store it? We are going to store it on a computer system, right? The various storage devices of a computer are divided into two categories. So basically we are not talking in terms of three types of categories. Basically, primarily, or you may say some standard formats are used, so we have only two types of storage. But there is another third type of storage is there between CPU and primary memory, that is our cache memory. So let us begin with the primary memory first. Primary storage stores and provides very fast. This memory is generally used to hold the program being currently executed in the computer. So whatever is executed in the computer, the CPU is accessing the primary memory for getting that data and get them executed in the CPU, right? So you have number of registers in that, you may have some storage part in that, you are maybe using some calculation registers also, like you have number of registers for that purpose, right? So behind that there are number of things that is going to be processed and then stored, right? So let us see the next point in this. The data being received from the input device, the intermediate and final results of the program. The primary memory is temporary in nature, right? The data is lost when you switch off your computer. So that's why we call it as what? Yes, temporary memory. The cost of primary memory is more as compared to secondary storage. Why? Because primary memory is the main memory and it is much more expensive. And again, if I am talking about cache memory, it is more precious, it is more expensive than your main, main memory. Therefore, most computers have limited private primary storage capacity, and we have more of a secondary storage like HDD, or you may be using hard disk, you may be using SDDs or such kind of devices, or pen drive also. So secondary storage are what? Secondary storage are a kind of an archive, like you have your hard disk, right? So storage devices is used like an archive. It stores several programs, documents, databases. Like suppose I'm taking an example. I want to format my computer, right? And like tomorrow I need to format my computer, and what I'm going to do? I'm going to use secondary memory, right? What I'm going to use? I'm going to use some pen drive, or I'm maybe, like if the data is large, I may be using the hard disk, right? For basically having the hard disk which is storing all the things, right? And I transfer my data from a computer, because I need to give my system, I need to format my computer, right? So I may be transferring all my data, all my documents to the hard disk, right? So that what happens, so that your data would be saved and stored, and you can basically format your system. Now what do you mean by format? Formatting means like when your systems become sometimes outdated, or you need to update your system. Sometimes it get directly updated, or some like you need to update your operating system, or sometimes you have such a memory, such a huge number of documents, you have basically occupied all the storage. Now you need to work upon it, right? Either to format, either to delete all the data if it is outdated, or you may say it is not required, right? Otherwise it won't be possible to have such kind of thing, right? Oh, the only thing is when we have in this the secondary storage, like you have the pen drive. If you are using the pen drive, that means you are you can transfer your data. So these are the different storage, or these are the different storage devices which you can use in your computer system, right? So this is the second important step of, yeah, architecture or the block diagram of this thing, computer system. Let us see the most important part, that is memory size. What we do in memory size, all the digital computers use the binary system. I told you the computer is only going to understand the zeros and ones, right? Each character or a number is represented by a 8 bit. Okay. So your computer system, each character, what it understands, it understands 0 or 1, and that is 2 in 8-bit code. The set of 8 bits is called a byte. So 1 byte is equal to 8 bits. A character occupies 1 byte space. And how much a character is occupying? That is 1 byte. A numeric occupies 2 bytes, right? And byte is the space occupied in the memory. So you have some limitation in the memory also. You cannot have such a kind of memory which can store everything. So because memory, I told you, memory is a very precious thing, and it is very expensive also. You cannot have such kind of thing like it's free of cost and you can buy any, and why to waste your memory? So like it's our brain only, like we have brain, and we have like work according to the we use the mind according to, or we use the brain according to our need. It is not every time we are engaging in some useless task or irrelevant task. It is not like that. It is with computer system also. The size of the primary storage is specified in kilobytes and or megabytes, or nowadays is terabytes also and gigabytes also. 1 kb is equal to 1024 bytes, and 1 mb is equal to 1000 kb. So 1 mb is equal to 1000 kb. The size of the primary storage in a typical pc usually starts at 16 mb. So minimum memory size we maintain for our primary memory, that is 16 mb. PCs having 32 MB, 48 MB, 128 MB, 256 memory are the quite like you may say commonly used, right? So these are the number of you may say these are the sizes of primary storage. But nowadays like softwares are such a occupying such a huge space in the memory, so it doesn't work. So what we have, like in our standard books we usually have such kind of memory storages, but nowadays we have huge memory sizes, because we need to have the different software that can install on our system and that can update also, right? So accordingly we use this kind of thing. The last thing we have is output unit. Now what is output unit? Output unit is whenever you give anything, like whenever you give output, whenever you give any instruction to the computer through input devices. Now you can, what you can do is you can process it first. The computer receives the information, the computer processes it through storage unit, and then it gives you the output using output devices. So output unit is used for showing the output, right? It is like a number of output units are there. You can use any of the output devices according to the need of the user. So let us see some of the output units, how we use output devices. The output unit of a computer provides the information and a result of a computation to outside world. So whatever you have given as an input, right, now it is going to be processed, now it's going to be stored, and how it is going to be converted into information, and how it is given to the user. So how the user is going to like have the output using output devices, right? It could be a printer, it could be a monitor, or your VDU, you may call it visual display unit. Other commonly used output devices, other commonly used output devices, your speakers when you receive the information. It could be a headphone, it could be a projector, it could be like number of devices are there. Now, let us see some of the units of memory, that is arithmetical and logical unit. All the calculations that are performed within the CPU, that are given by the user, that is performed under ALU. So it also does the comparison and takes the decisions. The ALU can perform the basic operations such as addition. So it has the capability to perform operations, as well as it is having the registers also, which is going to have like how you can process it and how you can store it using different registers, right? Whenever calculations are required, the control unit transfers the data from storage unit to ALU. Once the computations are done, the results are transferred to the storage unit, and then by the control unit, it is it is sent to the output device for showing, for displaying the results, right? Now what do you mean by control unit? What is the need of control unit? So yes, control unit is very very important in our basic architecture of computer. Why it is required? Let us understand. It controls all the other units in the computer. So you may have memories, you may have arithmetical logical unit, you may have different input unit, you may have input devices, you may have output devices. Now all these devices are controlled by what? Are controlled by control unit. The control unit instructs the input device where to store the data after receiving it from the user. It controls the flow of data instructions from the storage unit to ALU, right? And so basically you may check this thing from input to output. It is the control unit which is controlling the flow of data, right? Or flow of control also. It controls the flow of data instruction from the storage unit to ALU. It also controls the flow of results from ALU to the storage unit, right? So whenever it receives from storage unit to ALU, then whenever you want to store it from ALU to storage devices, so it is done by control unit. The control unit is generally referred as the central nervous system. So that's why I told you it is the main system which is basically controlling your input devices and storage devices and output devices, right? To the computer, that controls and synchronizes its working. So this is how it works, right? The control unit is, you may say, the heart of the computer system, the core part of the computer system, because it is controlling the left side also, and it is controlling, it is managing inside also, and it is managing outside also. Like now whenever it processes the result, the ALU, or it is stored in the storage unit, and now it is going to be displayed to the output unit, right? So let us see where these systems would be coming. So you have the CPU, right? Now what is CPU? CPU is basically central processing unit, which is containing the control unit and arithmetical logical unit and memory unit. So there are three things within the CPU part. The first is the control unit and ALU, that what we have discussed now, and the third thing is memory part also, right? The storage unit of the computer system are together known as CPU. The CPU is like your brain, perform the following function. So it is the CPU, right, in the computer system, which is called the brain of the computer, right? And because it is performing all the tasks using ALU, unit. It is controlling also by using control unit. It is storing also. How? By using storage unit. So ALU, control unit, and memory unit all are coming under what? CPU only, central processing unit, the heart of the computer system. Within that, the control unit is controlling all the control of flow plus control of data, flow of data, and instructions, right? It control all the units of the computer. It takes all decisions because it is having the brain, right? It is processing everything. Now let us see some of the examples, or you may say some of the types of computers we have. So we may be using a personal computer, like you have desktops, you have laptops, right? So that is like a single user is there, not a multiple people are working and they are connected with a network. That is not a kind of thing. There could be a like single user. So it is a single user computer system having moderately powerful microprocessor. So you may say it is going to perform within seconds. The result would be calculated within seconds. How it calculates? With the help of microprocessors. So this is the advantage of using the different microprocessors. Like if I am going to use any microprocessor nowadays, which microprocessor are like we are using? I am using core i5. What about the other things? Right, there are number of things which are being used. How it is used? It is used with the help of different you may say different systems, right? Different microprocessors are also coming nowadays, i5, i6, or you may say different operating systems are also used within that, right? Workstation is you may say when you have a number of computers, they are connected on a network, and then we are doing when then we are solving some problem, right? And again it would be a powerful kind of system. Then we have mini computer. It is, yes, it is meant for a multi-user computer system which is capable of performing the number of tasks, and it is supporting the hundreds of users simultaneously. Like if I'm going to ask about you may say any application, right? Like suppose I am using any application which is supporting 100 users at a time, right? It is going to respond hundreds of users. It has the capability to handle the multi user at a time. Then we have mainframe. So it's a basically not a small system. It is also a multi-user computer system which is capable of supporting hundreds of users simultaneously. Software technology is different from mini computer. So basically you have different architectures within them, right? It may be processing some like you may have multi programming, you may have multi processing, you may have parallel processing. So different processors, different you may say different techniques are used behind them to make the system faster, right? To make the system efficient, we may say. What is supercomputer? Supercomputer is, you may say, the first supercomputer was made by CDAC, right? It is an extremely fast computer which can execute hundred of millions of instructions per second. So now you can easily understood, like if a machine is supporting less number of instructions, then we have that kind of system. If a system is supporting hundreds of instructions, obviously it would be something else. Some we might be using some workstation kind of thing. If it is using thousands or hundreds of users, then it might be we have a mainframe kind of thing. But if we have a supercomputer, we may handle a very large amount of capacity in terms of handling the instructions per second, right? So it would be very advantageous for us when we have such kind of system. So according to our need, right? If we are like in working in an organization, or if we are talking about an organization, we might be using some kind of mainframe or some kind of workstation also, right? But if we are working on a huge scale, on a large scale, we might be using mainframes or supercomputers only, because we need the results. Like if we are working on some satellite or some security or some, you may say, some privacy or this kind of system, might be using the supercomputers, where we need to calculate, we need to process the results within seconds, right? So this is how we have a complete architecture, and how basically they are segregated in terms of speed and computing power, how they are, uh, you may say, how they are separated from each other, right? So hope you have understood the topic and like the session. Thank you.